audio audible and everything visible, right? Good evening, everyone. Let's start. So we're going to talk about the basic mechanism of tooth eruption and shedding. Now we all know, before starting this, I would like to say that we all know that tooth eruption is the process in tooth development only, right? And in obviously in the layman term, we say that it is the process in which the teeth, they enter your mouth and they become visible. So they enter your oral cavity and they become visible. So it's currently believed that periodontal ligament is going to play a very important role in tooth eruption. So the first human teeth to we all know the deciduous primary teeth, also known as the baby or the milk teeth, they erupt into the mouth around 6 months until 2 years of age, and this process is known as seeding. So these teeth are the only ones in mouth until a person is about 6 years old, creating the primary dentition stage. So before we talk about actually, the tooth eruption, we would just brush up about the tooth development. Already we have discussed this in detail, but we are just going through it again so that we can link. Okay. So because when we are discussing, I will be just giving you the numbers and not telling you the basic theory behind it, right? So during the development of embryo, we all know that there is formation of three germ layers: ectoderm, endoderm, and mesoderm. At 6 weeks of the intrauterine life, a horseshoe-shaped band, that's the primary epithelial band, it forms. And at the 7th week of intrauterine life, dental lamina and vestibular lamina, they form, right? We all know this thing, we've already discussed it, right? So all the deciduous teeth, they are going to arise from the dental lamina, and later the permanent successors, that is the permanent teeth, they are going to arise from the lingual extension of dental lamina, that's called the successional lamina, and the permanent molars. Okay, the permanent molars are going to arise from the distal extension. From the distal extension. Why? Because the deciduous molars are their successional lamina gives rise to permanent premolars. Okay, so that is why we have permanent molars arising from the distal extension of dental lamina. From the exam point of view, that all the disease arise from the lamina, later permanent successors arise from its lingual extension called the successional lamina, and permanent molars. So, talking about the embryological basis of the dental tissue genesis. So, we all know this is what we talked in the last class also when we were talking about the oral mucosa. That around the 27th day of gestation, you have the buccopharyngeal membrane here. So, I'm going to just annotate this for you. You have this is your your stomatodium, your primitive stomatodium. This is your primitive stomatodium, right? And you have this line here. This is the buccopharyngeal membrane. Okay, and you have the frontal prominence here, and you buccopharyngeal membrane is separating the stomatodium and gut. Okay, you can see this. So you have your stomatodium at this stage being lined by a stratified squamous epithelium, which is known as oral ectoderm. And the connective tissue cells which are overlying the ectoderm, they are ectomesenchymal in origin, and these together, these ectomesenchymal connective tissue cells along with the ectoderm, they are going to induce the tooth development later. So you have your buccopharyngeal membrane, this membrane that is made here rupturing at 27th day of the gestation. So when this membrane it ruptures here, this thing it ruptures here, so a connection is established between the stomatodium and the gut. Okay, so this whole connection is established here. So this is from where the basic basis of the dental tissue genesis is going to start. So when we've already epithelial band. So here is the continuous band of thickened epithelium that we see here that has been marked by this black arrow. Okay, so I can just again put this for you. So this is the continuous band of thickened epithelium, okay, which is forming. So oral ectoderm, what is happening is proliferating more rapidly than the adjacent cell. So that particular area proliferates more rapidly, becomes more thickened, and that leads to the formation of the primary epithelial band, which is the continuous band of thickened epithelium. This is roughly horseshoe shaped, and this thickening is first seen in case of the anterior midline. Okay. So initially, when the mandible and maxilla they are forming inside your embryo, they are placed just anterior posteriorly. It's later when the palatal cells they start developing that your mandibular starts moving down. Okay. So initially they are placed like this, and then the mandible starts moving down. Okay. You have here, this as the primary epithelial band. Okay, this is the picture that I am showing you for the primary epithelial band. Okay, this is the blue arrows. They are showing the upper one is for the maxilla and the lower one is for the mandible, and these both are your horseshoe-shaped primary epithelial band. And as you can see, the dental lamina is the one that forms your lingually. Dental lamina is formed lingually, and vestibular lamina is formed buccally. Okay, so vestibular lamina is the one that's marked in the picture. And so you have the primary epithelial band forming at the 6th week of the intrauterine life, which is a horseshoe-shaped band, and which further divides into a vestibular lamina and a dental lamina. So vestibular lamina is buccally placed and is going